Hello friends, in this video I am going to discuss about Lennard-Jones potential. Lennard-Jones potential is basically we are driving a potential energy for interaction between two atoms or molecule based on their distance and separation. Proposed by Sir Edward Lennard-Jones, this potential represents uh, two forces, attractive forces and repulsive forces. So important point is that there is no charge concept in Lennard-Jones potentials. Yes, there are some uh, new modified model like SPCE model for water, where they have explicitly added the charges, but in general, Lennard-Jones potentials doesn't have any kind of charge. So let's start. Suppose we have two rubber balls, then they are at infinite distance. So if they are at infinite distance, they are uh, almost there is no forces of attraction between them. Now let's consider another scenario where two balls are now coming closer. So now there will be a attractive force between them because they are coming close, and after some point of time there will be a distance where they will where they will have a equilibrium bond distance. So this represent a minimum potential minimum in potential energy. After that, if you try to just close if you try to further uh, decrease the distance between these two balls, definitely they will feel a very strong repulsion and they will try to pull them apart. So this whole scenario is derived by uh, Lennard-Jones. So let's see what is the equation look like. So equation is potential energy given by Lennard-Jones, which is a function of distance between two atoms or molecules, is equal to 4 epsilon sigma into r to the power 12 minus sigma into r to the power 6. Now it is very easy to now see that this minus term is a attractive term, this positive term is a repulsive term. So now if you just see again, if you just try to um, if you try to see it by potential, so if it is V and this is the difference between this is the distance between two particle, so definitely there will be a no forces of attraction because R is infinite. There is an infinite distance between two balls, so definitely there will be no forces. When you just decreasing the distance between two, and that means you are actually controlling the lower term, so attractive terms comes into play. Still there is repulsive term is because it is inversely proportional to 1 by 12, 1 by r to the power 12. So the change in this will be very low as compared to this, so there will be a forces of attraction, and after some time there will be a minimum when there is two balls are at the equilibrium distance. So by the way, this potential energy is 0 at 2 points, one when r is infinite and when r is sigma. This sigma is actually a van der Waals distance between two atoms. When two balls are exactly touching each other, this is called van der Waals distance. And this whenever you trying to find the Lennard-Jones potentials for two means a system, you will find two parameter, epsilon and sigma. So this epsilon is basically a depth of the wall, which represent bond strength, or whatever term you means. There are so many terms, but I generally prefer bond strength. So bond strength you can see now, and this sigma is actually a van der Waals distance. So now let's move to another like different way of looking at it. Now if you see, um, let's move to it to a okay. This is a very simple, actually sometimes it happen. Yeah, so let's see. Again, potential is equal to 4 epsilon sigma into r to the power 12 minus sigma into r to the power 6. Now if you see, this is a repulsive term. As I already mentioned, it is proportional to 1 to the power r to the power 12, and if you see, definitely it will be on the upper side, means upper, uh, uh, it is above 0. Now if you just see the repulsive term, attractive term, it will be like in the below side. So this is equilibrium distance, and the depth is E, and this is 0. Now can we just can we just see into a 2x, like it is basically a sum of these two terms. So at like before any bond formation or any equilibrium distance, always the attractive terms try to dominate over a repulsive term, and whenever there is after like you can say from this point to this point, whenever you try to just lower the distance between two atoms, definitely there will be very strong repulsion. But is it useful that suppose if you just decrease the distance? Yes, it is useful when there is a nuclear fusion, like two smaller atoms combining to form a nuclear fusion. So this is actually a very important term. So it is not that it is means every time this repulsion term is not useful. It is useful, but in the case of nuclear fusions. So now let's try to go into mathematics. So as I already told you, there are two uh, there are two places where this potential is 0 when r is infinite and r is sigma. So let's see, let's find out the first derivative of Lennard-Jones potential. So it is very simple, because the first derivative of the potential energy, or you can say negative of this potential energy with respect to distance, it is a force. So can we find out the force? Yes, it is very difficult. It is very easy. So when you just find out the potential energy forces for this system, it is comes around this equation. You can do the mathematics. I am just sharing the screen. So whenever if somebody have any confusion, you can just go through this video, and you can, it will be very easy for you to just see how we have derived this force. Now now forces, if you just do some preliminary mathematics, you will come out to with the that force is equal to now it is proportional to uh, r into 13 and r into 7. Sigma remains same, and 24 is like number somewhat changing. So whenever like at equilibrium distance at this point, this r is equal to r0, means the distance between two atoms, now it is r0, so f is equal to 0, and therefore using the equation, this equation, if you just put the 0, you will come out to be a relation called r0 2 into the power 6, 1 by 6 and sigma. As I already told you, this sigma is a van der Waals radius. Basically sometimes this r0 is represented in terms of, or r minimum represented in terms of sigma. So it is 2 to the power 1 by 6 of sigma. Now let's again, means we can, like initially we were minimizing with respect to r. So if we minimize with respect to sigma, we will come out to be like same conclusions. Again sigma r0 will come out to the power 1 by 6. So whether you can, means there are two variables, like whether you come with the sigma or whether you come with the r, means whether you minimize with respect to sigma, whether you with respect to r, definitely the final conclusion for r0 will be the same. Yeah, forms will be different, but final conclusion will be the same. So this is the beauty of mathematics. Now we can also find out whether this represent a minima or maxima. So you have to find a second derivative of the VLG. So forces you have already calculated, and if you just do some more mathematics, and you find out it will be come out to be a positive term. Just putting this r into like, if you just put r, value of r in terms of sigma, or you have to just put the values. Okay, so you will come out to be a some very nice relation, and it will be around 72 epsilon r 0. So it will be like positive. So if it is positive, then definitely it represents a minima. Similarly, if you do it with sigma, you will again come out to be the positive term. So I think that is the term. So this is very, like, it is my, not my, it is an assignment which I have like solved it by myself. So definitely you can use it, I think. And I was going through so many things in the YouTube, so I found it okay. There are explanation for Lennard-Jones potential, but it is very difficult to find out the mathematics part. It is difficult, and sometimes people who are not from this mathematics background, they find it very difficult to do it. So I have like recorded this video in very uh, good time, so you can stop the video and pause the video, and you can just see how mathematics is going on. So I hope you like this video, and thank you for watching this video, and please subscribe to our channel.